For our final project, we attempted to predict the 2024 March Madness bracket using machine learning algorithms. To do this, we explored different classification methods such as logistic regression, decision trees, k nearest neighbors, and support vector machines or SVM. We gathered our data from an online source and copied and pasted it into an Excel sheet. After we had gathered all our data, we spent a while cleaning it as it was a lot messier than we had originally anticipated. We cleaned the data in Excel and by using a few lines of code in Python.
We started our data exploration by essentially looking at what the data consisted of and deciding what variables we wanted to use to train and test our models. We started with 3 data sets: tourney stats, team stats, and player stats, but in the end only used team stats and tourney stats because there were too many inconsistencies within the player stats data. There were some teams that had a lot of players that were in the top 1,000 but went out in the first round, and there were teams that had no players in the top 1,000 that went all the way to the Elite 8 in past years.
We tried to use variables that were not highly correlated when testing our logistic regression model so that the model would not overfit the data. Through our exploration, we were able to decide which classification models we wanted to continue with during our analysis. Decision tree classification gave the lowest accuracy all around, and so we went with SVM and KNN. Logistic regression was similar to SVM and KNN, but these two made more sense for our model, so we went with them.
When it came time to apply the model, we used combined data from 2009, 2016, and 2017 to train the data. We then used data from this year, 2024, to test the model. We went through each round: second round, Sweet 16, Elite 8, Final 4, Final 2, and the championship, by subsetting the data to only contain the teams that the model predicted to win in the previous round.
The model that predicted the most correct bracket was the SVM model. KNN was super close, but it failed to predict 2 teams for the final 2. KNN was able to predict that UConn would be in the championship, but could not predict a competitor for them. SVM was also able to predict that UConn would be in the championship, and was also able to predict that Purdue would be their competitor, but ended up predicting that Purdue would win overall.
It was very exciting that our model was able to predict the final 2 and a large portion of the matchups correctly, but the one flaw within our model was that we were not able to tell the model who played in the first and second rounds, so sometimes when 2 teams played against each other, it would predict both to win. We saw this trend with KNN and SVM, however, it was much more prevalent with the SVM model. To account for this, when creating the final bracket overall, we looked at both brackets that were created, and where there were 2 teams in one model, if the other model had one of the teams selected, we would choose the team that appeared in both models.